Hello everybody, welcome to today's mini lecture on rational equations. Rational equations are equations containing some rational expressions in addition to some polynomials. Examples are shown here. Rational expression equals rational expression minus rational expression, or rational expression equals rational expression minus polynomial. Also, rational equations are usually treated early in algebra courses, usually right after linear equations. They are not as easy as they look and have some pitfalls. In this mini lecture I want to show you how to solve rational equations, and I will point out some of these pitfalls. Look at the following rational equation. X plus 3 over x squared plus 3x equals 2x plus 2 over x squared minus 1 minus 2 over x. Wow! What a hammer equation. Can't we start with something simpler, you may ask? Yes, we can. Why don't you make it simpler? You should always routinely try this step first. So step 0. Simplify each rational expression by factoring numerator and denominator and cancelling if possible. So now you need your factoring toolset. All terms in x squared plus 3x have a common factor of x. Therefore, x squared plus 3x equals x times, in parentheses, x plus 3. All terms in 2x plus 2 have a common factor of 2, so we get 2x plus 2 equals 2 times, in parentheses, x plus 1. And x squared minus 1 is a difference of squares. Thus, x squared minus 1 equals x plus 1 times x minus 1. Then the rational expressions with numerators and denominators completely factored and common factors cancelled are as follows. X plus 3 over x squared plus 3x, so we factor the denominator, we get x plus 3 over x times x plus 3, and we cancel the x plus 3, so we get 1 over x. And the other one, 2x plus 2 over x squared minus 1, we factor both numerator and denominator, we get 2 times x plus 1 over x plus 1 times x minus 1. We cancel the common factor of x plus 1 and we get 2 over x minus 1. Therefore, the hammer equation really looks a little more innocent. It's 1 over x equals 2 over x minus 1 minus 2 over x. So what makes rational expressions difficult? Obviously, the rational expressions in it. So we want to get rid of them. That's actually the first and almost only aim when facing rational equations. Get rid of the rational expressions. This is done always by multiplying the equation by the LCD, the lowest common denominator of the occurring denominators. So we have step 1, always multiply the equation by the LCD. Why? Since multiplying allows you to cancel the denominators in all rational expressions. This way the expressions become polynomials and we get a polynomial equation. There's only one problem here. How do we find the LCD? Remember that the LCD is defined as a polynomial that 1. Has all occurring denominators as factors. You may say it's a CD, a common denominator. And 2. It's also the smallest polynomial with this property. Very often the LCD is just the product of all occurring different denominators. This product always obeys property 1 above, but is sometimes not the lowest CD. So my first warning. Sometimes the LCD looks easier than the product of these different denominators. It is easier, but it's still more difficult to find, as I will explain in the following digression. If you don't have much experience with rational expressions, you may want to skip it and continue at 5:30. So here's how you find the LCD of any rational equation or rational expression. 1. Factor all denominators completely. 2. List all occurring different factors. So if a factor occurs in several denominators, then the factor is still listed only once. 3. Raise each factor in the list in 2 by the largest number by which it is raised in any denominator. For instance, if the factor x minus 1 occurs in 3 denominators, once as x minus 1 squared, once as x minus 1 cubed, and once as x minus 1, then we raise x minus 1 to the power of 3. We have x minus 1 cubed. And 4. where LCD is the product of the factors in our list, each factor raised to the power as explained in 3. So let me give an example. The LCD of the rational equation shown here is x cubed times x minus 1 cubed times x plus 2. In our first example, the LCD is just the product of the denominators x and x minus 1, so we have the simpler case. Although x occurs twice as denominator, it is used only once, since we only consider the different denominators. So you multiply by x times x minus 1, what do you get? So here, time for our second warning. Don't confuse raising a rational expression and multiplying an equation. Never ever confuse these techniques and when to apply them. Raising only applies to rational expressions. Multiplying only applies to equations. When you raise a rational expression, it looks different after, but is still the same. When you multiply a rational equation by an expression, every term of the equation, every rational or polynomial expression in it has changed. But the equation is equivalent to the previous one, has the same solution set as the previous one, provided you didn't multiply by 0. When you raise, the new stuff occurs both above and below the fraction line. When you multiply, the new stuff occurs left and right of the equation. To be more precise, in every term left and right of the equation, but not in the denominators. So if you multiply our simplified rational equation 1 over x equals 2 over x minus 1 minus 2 over x by the LCD, which is x times x minus 1, you get x times x minus 1 over x equals 2 times x minus 1 over x minus 1 minus 2 times x minus 1 divided by x. Please note that no denominator has changed, at least not initially. Eventually they all will vanish when you cancel. And you will always be able to cancel. Every rational expression will just collapse into a polynomial. It was just the point of raising by the LCD. So after doing so, after cancelling x in the first expression, x minus 1 in the second expression, and x in the third one, we get x minus 1 equals 2x minus 2 times x minus 1 in parentheses. That's it. From now on, you are on your own. You will get a polynomial equation if it has degree 1, as in our example. It is rather easy, isn't it? If it is a quadratic equation, you need a quadratic formula. But if it has higher degree, well, there are still some methods there, but you will only succeed in special cases. So the last step of our procedure, step 2, solve the resulting polynomial equation somehow. In our example, we distribute and get x minus 1 equals 2x minus 2x plus 2, or simplified x minus 1 equals 2. Then we add 1 on both sides and get x equals 3. This is the solution of example 1. We plug x equals 3 in and it checks, as you can see here. Now let's do another example. Example number 2. X over x squared plus 1 equals 2 over 2x minus 1. Did I hear cross multiplication? Forget cross multiplication. This is not a concept you need to remember. It is just a special case of our general method of multiplying the equation by the LCD and cancelling. The LCD is x squared plus 1 times 2x minus 1. Multiplying our equation by this LCD, we get this equation here. Then we cancel x squared plus 1 in the first expression and 2x minus 1 in the second one, and we get x times 2x minus 1 equals 2 times x squared plus 1. Of course, this is a result you can get, slightly quicker maybe, using cross multiplication. Then we distribute and get 2x squared minus x equals 2x squared plus 2. It looks like a quadratic equation, but we are lucky the quadratic part vanishes. We just subtract 2x squared on both sides and get negative x equals 2 or x equals negative 2. Please check yourself to confirm that this value works. So now let's move to our third and last example. It's given here. First we need to factor x squared minus x minus 2. It is equal to x plus 1 times x minus 2. So we plug it in. And now the LCD equals x plus 1 times x minus 2. And we multiply the equation by it. Here the next pitfall is waiting. The negative 1 stands at the side of the left expression, humble and passive, as if it would have nothing to do with the rest of the group. But you still have to multiply it. So a serious warning, don't forget to multiply non-ratios by the LCD. When you do so, you get this equation here. Then we cancel in each expression. We get this equation. We distribute. And we open this parenthesis here. Then we collect like terms and we get 3x equals 2x plus 2. And finally, subtract 2x plus 2 to get x equals 2. So, is this it? Is x minus 2 the solution to our rational equation in example 3? Try to plug it in. You get rational expressions with a 0 in the denominator, so x equals 2 does not work. It is not a solution. What did we do wrong? Really, not much. But when we multiplied the equation by the LCD, we multiplied by something which equals 0 in case x equals 2. Remember that multiplying an equation by 0 does not result in an equivalent equation having the same solutions. Therefore, the procedure was only correct for x not equal to 2 and x not equal to negative 1. So here's my last warning. The zeros of the LCD are not possible as solutions. Either you exclude these values from the very beginning, or you check your solutions. Alright, thanks for listening.